Hello, everyone. We are Team 13, and our project is on audiovisual emotion recognition. So, emotion recognition is a non trivial task for humans because we can identify emotion through audio or visual representation. Equally, we believe it's important for machines or systems to be able to do the same thing to identify emotions from people in terms of it can be very useful for security reasons and also development in HCI and social robotics. So in this project, we are trying to improve existing audiovisual recognition models and trying to recognize emotions based on one modality in the absence of another.
The model we are improving is a model by Katerina Tumachenko et al. Called from the paper Self-Attention Fusion for Audiovisual Emotion Cognition with Incomplete Data. In this project, we've used two datasets, CREMA-D and RAFDES, and the main differences are that CREMA-D has 5 emotions, while RAFDES has 8 emotions. CREMA-D has multiple accents, while RAFDES has only one accent. The baseline model experimented with 3 different models, which are late transformer fusion, intermediate transformer fusion, and intermediate attention fusion. They've continued with intermediate attention fusion, which gave good results. After replicating the model, RAFDES and CREMA-D gave 62.98 and 19.16 accuracy. RAFDES performed better because it's the one which the model was trained on. The original data from the model gave 79.3 accuracy on RAFDES and 67.72 top 1 accuracy on CMU Mosaic. After experimenting with different accents, we've realized that the model performs well on anger compared to other emotions. Next, my colleague is going to talk about the methodologies we've used to improve the model.
For the methodology, we decided to focus on the immediate attention fusion as it had a better results from the initial training. So for the modification, we re-implemented our attention model for better efficiency and improved code quality. We also processed the CREMA-D data set to allow it to train on the baseline model as it had the largest data set. And then we added a residual block on the video and an audio model to prevent the vanishing gradient from happening. And then for the video model, we changed the activation layer to sigmoid as it performed better, and then GELU for the audio model, which also performed better. So for the residual block, this is the architecture that we had. We had a stride of 3, and then a channel which comes in from the audio video model, and then we had a shortcut which also had a kernel of 1 and a stride of 1, and then a pattern of 0. So this is the architecture for the audio modality. We had 4 residual blocks, and then it's similar also for the video modalities. So for the results, the CREMA-D dataset performed really well. We had accuracy of 9.3 with a precision of also 91.3. But on the RAFDES, which was the out domain datasets, it didn't perform really well. We had accuracy of 40%, and then a precision of 39%. On the CREMA-D datasets, the only audio performed really well, and then the video to perform well with 91% accuracy across board. And then on the RAFDES, the confusion metrics showed that most data sets were actually false negative or false positives, which was really not good for the test. And so the out domain data set did not really perform well, but the in domain data sets, which was the CREMA-D, performed really well. In summary, the testing on the RAFNet, which was the out domain, showed that the emotions was not classified really well, so we could improve on the model by like changing the data set, maybe the variety of the data set, or including different data set like the Mosaic to make it better. And the model performed best on the CREMA-D data set as it was the in-domain data set. Future work we could implement on live emotion detection. So instead of just doing a static video, we could do live detection, and then we could increase the classes of the emotions for better classification without generalizing. Thank you.